Early research on air. In the field of chemistry, the understanding of the word air has undergone radical change. Air, for John Maiu, a 17th century chemist, was essentially a receptacle for airborne particles, and through them manifested a variety of chemical properties. But although Maiu and a few other chemists did detect specific chemical properties in what we call gases, including carbon dioxide, most chemists left them unaccounted for until the beginning of the 18th century. As chemists became aware that the atmosphere itself, and not just particles within it, had a role to play in combustion, respiration, and other reactions, they did not attribute this to the chemical properties of air, but rather to substances that air could absorb and release according to circumstances. Thus, air provided a physical environment in which some reactions took place. In the early 1700s, air was widely seen as just such an environment, and air and the air were one and the same thing. Chemists were not in the habit of regarding airs or gases as having different chemical properties. There was simply air. One obvious reason for this was practical. Chemists could examine solids and liquids, exposing them to a variety of tests and seeing how they contributed to assorted reactions. Chemists had, however, no comparable way of examining air, and they came to view chemistry as the sum total of the reactions of solids and liquids, excluding gases. Chemists stressed chemical qualities over physical properties like weight and let physicists deal with air. Chemists generally did not examine air, and they did not try to weigh it. That does not mean that chemists did not weigh substances. They did a lot of weighing, and pharmacists and metallurgists did more. But weighing gases was outside their brief. In the Encyclopedia of Diderot and D'Alembert, published between 1751 and 1775, readers were told that the incoercibility of gases will remove them from our researches for a long time to come. By the time of the encyclopedia, however, this had begun to change. One of the first and key sources of change was the invention by the Reverend Stephen Hales of a new instrument, the pneumatic trough. This instrument is important for what it made possible in the handling of air. The history of its invention and early use illustrates the difference there may be between the motives for inventing a device and the ways in which that device is used. Hales was a botanist and chemist as well as a physiologist. He wrote a book in 1727 investigating mechanical subjects like the pressure of sap in plants. But Hales went further, addressing chemical as well as physiological questions. He urged chemists to consider air chemically. He described an instrument for washing the air produced in the course of a chemical reaction. He wanted to get rid of impurities in the air by letting it pass through water. Air passed from a reaction vessel through water in a trough or tube, and then into a second vessel that was partly filled with water and that could capture air. In devising this apparatus, Hales had coincidentally furnished an instrument for catching and holding air, which could then be subjected to various tests. Used in this way, the apparatus became known as the pneumatic trough. Half a century after its invention, it became a staple of the chemical laboratory. It also became one of the key instruments in the reform of chemistry that we know as the chemical revolution, because it was essential to incorporating a whole new state of matter, the gaseous state, into chemistry alongside the already studied solid and liquid states. Once that step had been taken, it was possible to speculate and then to demonstrate that the gaseous state, like the solid and liquid states, could contain a variety of chemical substances. This was an enormous step, and it did not happen overnight. Hales had shown that air could be contained, washed, purified, and tested chemically as well as physically. This, however, did not lead him to think that there was more than one kind of air. Air, for him, remained air, not one of a number of airs. Other chemists would take that essential step.